Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Inshallah, today we will continue back chapter 2.2. In the previous video, I asked you to watch. It was basically the same thing, but today we will continue back, and I think we stopped at slide 57. So today we'll just backtrack a little bit more, and I will explain to you on what is okay, on what is the what can we do? Okay, so in file protection, what we have done in the previous class, we are talking about file system. So what file system are we talking about? We are talking about how the operating system handles all your files in the operating system. Okay, so there are a few methods that is employed by the operating system, among which is in locating your files. One is the sequence method. Another one is called the random access method, and this is how the operating system will locate your files. And the operating system will also provide file protection to all your files. Okay, so who can read your file, who can write your file, who can execute, append, delete, and list. Okay, so this is how basically the operating system will provide access to certain types of file in the inside your hard disk. Okay, so there are three types of users, or three types of people using files inside the operating system. One is the owner. Okay, so the owner is the person who, or the user who creates the file. Okay, next we also have the group access. Okay, who does this owner belong to? And we also have public access. Public access means that's the most simplest. It means anyone who can use the operating system or can access the file, but public cannot read or write, but simply execute the file only. As compared to the owner, since that user is the creator of the particular file, so the owner of the file can read or write and can also execute that particular file. As compared to another one is called the group. The group, on the other hand, can only read and write but cannot execute. Okay, so these are certain examples provided by the operating system. So if you want to change the mode of a particular file, meaning to say we want to change the access of certain types of user, the command in operating system, in a DOS operating system, is what we say as ch mode change. Ch means change, mode means change the mode of the type of users, and this is the number, and this is the unique number provided, and this is the file name. This is an example. Right? So the example of the file name here is game, right? So first we changed number 7 into binary 111, 6 into binary 110, 1 into binary 001, which means that the owner has read, write, and execute access. That's why you need by 111. And the group, which is the second number here, which is number 6, 110, has only the read and write access, but no execute. Okay, you can see here there's no X. And the public has, which is number 1, has only access, has public has, okay, the public has only to access, can only execute the file. Okay, that is why you have 001. Okay, so read is the first number, write and execute. So if we change it into a different format, D means directory, which is this one here. That's why I put the same font color. Read, write, read, write, execute, RWX. This belongs to the owner. Then you have RW dash, read, write, but cannot execute. So it's a dash. And public has no read, no write, but can only execute. That's why you have two dash here. Dash means empty lah. Okay, and X is the file, and X is execute. Okay, we can also do another method. This is to change mode, meaning you change a particular file. But if you want to attach a group to a file, we can do another command which is called the change group G, okay, to the file, meaning G, change a group G. That means you have a particular group already. That means it can be A, B, C, D, or so on. But automatically, when you use this change group to G, means whatever, let's say here, owner and the group has a read, write, access, automatically this group by the name of G has this read and write access. Automatically, that means you are including a new group inside the file. Okay, are you with me? Hello, hello. Can you all hear me?
Yes, sir.
You can. Okay, good. All right. So this is how the Windows will do it in the Windows 7. You just right-click a particular folder and see whether it's read or write. Okay. Okay. Let's do this one. I give you 1 minute to, and who is the fastest which can come up with an answer will get 2 bonus marks. Okay. Starting from now. Analyze the permission granted for command change mode 271 for a particular directory. Okay. So first thing is you must change the number 2 into binary, and then number 7 into binary, and number 1 into binary. Then you do it in this format. Okay. I want who can fastest type the answer on the chat box get 2 marks. Answer is either A, B, or C, or D. So what's the answer? Can you get the answer? Anyone? And one. First, you change the number 2 into binary, and then number 7 into binary, and number 1 into binary, and then you change it, and you do it in this format. B. And someone says C. Someone says B. Faris Asaruddin says B, and Hazira, you say C. Anyone else? C, 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 C. Correct. So the answer is C. Okay, correct. The answer is C. Faris Nasaruddin. Faris Nasaruddin. You have to change the answer back. You have to, sorry. You have to change it into binary first. Okay. Change it into binary like this, and each of the numbers you change it into binary, and then you will see the answer. Okay, You have to change each and every one. So what is 0? Sorry, what is number 2 in binary? What is number 7 in binary? And what is number 1 in binary? So obviously, even if you by looking at this, you know number 1 here is 001. So 001 is dash dash x. So the answer cannot be B. It's either C or D. So upon which you do number 7 pula. Okay, number 7 you do the same thing, you get the answer. Okay, so number 7, the answer for this question is, yeah, that's all correct. 010, 111, 010. So you get the answer is C. Correct, correct. No, Anis. Okay, so I will give all of you 2 marks, whoever who has answered this. Okay, I'll just copy. Okay, dan salah pun tak apa. Okay, so whoever has responded, which is this one, all these people will get 2 marks from you. Okay, 2 marks. Apa yang tak jawab? Oh, apa? Okay, next. Next slide. Okay, so this is the same thing, but is in Unix operating system. You still have the same, the same format. However, you can see the format here. Okay, you see the format here, and this is in the root directory. And the daemon means, or the daemon here. Kalau daemon, what it means is if it's in a C Windows C file, is the C location, C prompt. That's the daemon in Unix. Okay, and each root file is what we say as a directory in Windows. Okay, it's the same thing. Okay, and yeah, this is how it is done. Okay, this is for Unix. And next we look at file allocation. Okay, how the operating system stores files inside your hard disk. Okay, so by default, operating system stores in what we say is a contiguous sequence of bytes, meaning one after another. Okay, one after another. And we have to look at what is the meaning of fragmentation and what is the meaning of internal and external fragmentation. Okay, so when we say contiguous fragmentation, just imagine this is your hard disk. Okay, so your hard disk, and there are boxes here. Each of this block here has a size of 5 kilobytes. Okay, 5 kilobytes. Okay, and as you can see, there are certain colors I have noted down here: green, red, and the orange and blue. So each of these box has 5 kilobytes. Let's say the green file over here, file number 1. Okay, file number 1 has the size of 15 kilobytes, 15, meaning to say operating system would allocate 3 boxes. Contiguous means side by side. So the operating system will allocate 3 boxes side by side. It will not allocate box number 1 and then box number 2 and then box number 4. It will allocate all the boxes side by side in the contiguous allocation method. Let's say in the same let's say we're looking at the green box, sorry, the red boxes. Okay, there are 6 boxes here. Let's say the file size of file number 2 is 33. Okay, 33. Oh, sorry, not 33. Let's say it is 27. 27 kilobytes. Okay. 27 kilobytes. So you have 1, 2, 3, 4, 5, 6. 6 times 5 is 30. Okay. So this is okay. And you have file number 2. The size of file number 2 is 27. So you have an extra of 3 kilobytes. So the 3 kilobyte means it's what you say as internal fragmentation. fragmentation. Internal fragmentation means is an empty space within each block that has not been utilized. Okay, because file number 2, the size is 27. However, each block here is only 5 kilobytes. So 5 kilobytes, so 27 means it's about 6 blocks. 1, 2, 3, 4, 5, 6. But if the operation system gives it 6 blocks, it means it's giving actually 30 kilobyte. So it has a remaining balance of 3 kilobyte. So the 3 kilobytes is what we know, is what we say as the internal fragmentation, empty space within the block. You cannot give 5 blocks because 5 times 5 is 25. It's a shortage of 2 blocks. Okay, because the file 2 is 27 kilobytes. Okay, so this is how external fragmentation looks like. External fragmentation, on the other hand, is the empty space which is outside the operating system. Outside. Internal is inside, this is outside the operating system. So as you can see, there are empty spaces here, the gray one. So these are empty spaces outside the file. Okay, outside the file. This diagram is external or internal fragmentation can happen in either your hard disk or your memory. So this is what we say as the, sorry, it can happen inside your hard disk, not memory. Sorry. Okay, but as you can see here, there is empty spaces outside the process, outside the file system. Okay, this is what we say external fragmentation. There is no blocks. There is enough memory to run process 7, but the memory is not contiguous. What does this mean? Meaning, let's say we have a new process coming in inside here, but there is enough memory. Enough memory means if you plus this empty space, this one, this one, this one, this one, this one, you can put in number 7. But because the spaces are non-contiguous, that's why we have kept around. If the spaces were contiguous, side by side, then we can put in process number 7. Okay, this is on the other hand internal fragmentation. As I explained just now, it is inside the memory. This is inside the memory. It's an empty space, however, you cannot use it because it's inside. Okay, let's go a bit deeper on file allocation. There are 3 types of file allocation: contiguous, linked, and index. Okay, this is how operating system stores a file using the technique called contiguous allocation. It has a directory. This is a directory which is called a file allocation table, FAT. So inside this file allocation table, it keeps the start of the file and the length of the file. Okay, it keeps the starting address of the file and the length of that address. For example, let's take file mail. Okay, it starts at 19, which is here, and it's 6 spaces. 1, 2, 3, 4, 5, 6. It ends at space number 24. Let's take the file called F. Starts at 6 and the size is 2. So 6 and 7. Okay, so this is contiguous. Anyhow, it should be contiguous side by side. Okay, let's say there's a new file, file A. It needs, let's say, 4 or 5. Okay, 5. It needs 5. Okay, so file A cannot be going inside here because this is 2, 3, 4, 5. No, not enough. How about this? 8. 1, 2, 3, 4, 5. Okay, this is more than enough. Okay, 8, 9, 10, 11, 12. Okay, this is file A. It's all side by side. Okay, the advantages of using contiguous block is simple. Quite simple. You can have random access and there's no space for wastage. Okay, next you have linked. Linked, on the other hand, you start with the same thing. This is called the directory of our allocation table. Here you have the start and you have the end here. You only have the start address, which is number 9, and each of this block will keep the address of the next block. So number 9 keeps the address of number 13. So number number 16. Okay, and number 16 will keep the address of number 1. Number 1 will keep the address of number 2. Sorry, number 2, and then number goes down. Okay, up to 25. And when it reaches -1, it means end of file. Okay, so this is what we say as linked. Okay, what's the main difference between contiguous and linked? Well, contiguous does not have addresses side by side. It's not something it can be anywhere, any part of the hard disk. Okay. So linked, again, simple, free space, no wastage, no random access. Yes, you cannot have random access because the files are everywhere, every part of the hard disk. Next, you have the index. The index, on the other hand, again, you start with the same thing, but the index will keep the address of all the other locations. Okay, that means you start at 19, and inside 19, you will keep whereas the next one is 16, whereas the next one is number 1, whereas the next address is number 10, whereas the next address is 25, and end of file. -1 means end of file. Okay, so index location keeps, okay, keeps the addresses of all the other addresses. Okay, so this is comparison of all with the random access, contiguous has, access, linked does not. Data fragmentation, this is internal data fragmentation, and this is external fragmentation. Okay, next we go into what we say as file allocation table. I'm sure all of you have heard of this before. FAT12, FAT16, and FAT32. What does this mean? Okay, file allocation table. FAT means file allocation table, and it has it keeps track of all the files inside your hard disk. Okay. Okay, and why is it called 12, 16, and 32? Each block, as I showed you here, each block here, if I say 12, it means each block can take in about 12 bytes of file. Okay, meaning it cannot go more than 12 bytes. That 16 is also the same. It cannot go more than 16. It cannot go more than 32 for FAT32. Okay, FAT32 was very common in the 80s, or not so the 80s and 90s. FAT12 is very old system. Okay, and then we have something which is called the NTFS, new technology file system. Okay, this is the latest one. All of you are using. I'm sure all of you are using. Okay, let's tell you the difference between FAT 16, 32, and NTFS. It's quite simple. Meaning, if you look here at point number 3 here, maximum file size 2 gig, 4 gig, and unlimited. This means, okay, if you take FAT32, okay, FAT32 here, let's say your hard disk size is 10 gigabyte. In FAT32, each file, the maximum size of a particular file is only 4 gigabyte, even though your hard disk space is up to 10 gigabyte. You understand this? Even though your hard disk space is 10 gigabytes, but maximum per file, which is under FAT32, is only 4 gigabyte. unless, but if you compare to NTFS, limited only by the volume size, you can have any number, how big, as long as the file is big enough inside your hard disk, then you can have it. Okay. File name length, number one, you have between 1 to 8 characters, but in NTFS you can have up to 255 characters. File extension, you can have, file extension means like testing.docx, these are extension files. But for FAT16 is only a very short extension, but in NTFS we have a very long, very big extension. And then max volume size. This one here, max volume size, 2 gig, 32 gig, and up to 2 terabytes. This is what do you mean by this? Volume size. It's like this. Let's say you have a hard disk, let's say a small hard disk, 100 gigabyte. Okay, 100 gigabyte, and you want to do a few partitions. Okay, in a FAT32 file system, each partition maximum size is 32 gigabyte, meaning you cannot go more than 32 gigabyte for one particular partition. Okay, so same thing as for NTFS, you can go as how big you want, but it's normally between around 2 terabytes per partition. Maximum volume size. And maximum files per volume is unlimited for FAT32 and NTFS. Meaning, in FAT16, you can only have about 6,500 files per volume, per partition. Okay, and these are the types of operating system that uses it. In NTFS, yes, you have a security level support, meaning you can assign security. That means you can put read only or write only or so on and so forth. But for FAT16 and 32, you cannot do that. Okay, so this is what it is, new technology file system. Started in 93, supports a disk size of 256 terabytes, primarily used in Windows 7, Vista, XP, 2000, and so on. Okay, so that is the main difference between FAT16, FAT32, and NTFS. There's another one here. Yeah, here we go. This is how it looks like inside your hard disk. If you were to right-click on the C drive, you are able to see this NTFS, new technology file system. Okay. Okay. Extension means a file extension. There are 3 until 5 letters at the end of the file name, meaning you can have, let's say your file name is testing dot, you can have up to 5 letters. Okay, up to 5 letters. As now most of you know you only have about 4, but you can extend this to up to 5 letters. For example, testing dot EOCX, that's 4, but soon you can go up to 5. Okay, that is only for NTFS. In fact, FAT2 and FAT16 or FAT12 is only up to 3 5 letters extension. Okay. Okay. So file letter extension, just the same thing. So, okay. All right. That's all for today. Very short one, just to finish up this chapter. Okay. So we have finished chapter 2.2. All right. So we have finished chapter 2.2. Let me just go back and see what have we covered.
I have a question.
Oh, yes, for him.
Is it as FAT and FAT32 is the same? Can you hear me?
Can you repeat your question?
Can
you repeat your question?
As FAT and FAT32 is the same or different file system?
FAT32 and what did it? And XFAT. Okay. Okay, I get you. Okay, FAT32 and XFAT are totally 2 different systems. Okay, FAT32 is an old system whereby each block takes about 32 bytes. XFAT is an upgrade of this one. Sorry, an upgrade of this one only. Okay, it is the same thing. Okay, it's the same thing for new file technology system, but it's an upgrade of this. Okay, an upgrade sahaja daripada sini, extract. So extract and 32 is two different things. Okay, extract lagi besar daripada NTFS. Okay, so yang ini maximum file size dia, that means one particular file, maximum it can go is 4 GB. NTFS, tak kisahlah how big you want, boleh juga. As long as it can fit inside your hard disk, that's fine. Okay, so my answer to you, extract and FAT32 is two different things. It has different capability and everything else.
Okay, sir. Thank
Okay,
you.
any other question? All right. Any other questions? Okay. So this one, I asked you to watch the video last week. This is quite simple, very straightforward. This two-level directory, file system, path name. Okay. So path name also you need to know. You have the absolute path and the relative path. So the absolute path, as you can see here, it has the whole location from C / folder name until you get the folder, until you get the file. But for relative path name, you only have the second last folder to the file. Okay, that is a relative path. In terms of speed, this is much more faster because it knows where to look for. In terms of this is much more slower relative because it has to go to one by one by one. The only thing given is the folder before the file. Okay, so this is much more slower. Okay, so this is the same thing. Tree structure can also call some kernel files, and then you have certain advantages and disadvantages of using the graph directories. Okay, all right. So you have any questions for me? Ada orang ada soalan ke?
No, sir.
Okay, all right. So make sure you sign your attendance, and I will put up this video on my YouTube channel. If you want to hear more, you can go and hear more. And I'll make sure I will give the 2 extra marks to all of these people. Let me just copy back here. All right. So these are the people. Here. All right. Okay. So these are the people. Okay, so thank you so much for attending my class today. Make sure you sign your attendance, and I will see you in the next class. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, sir.
Thank you, sir.